Alright, so I'm going to show you how to insert and remove elements into a binary search tree. So the first element to insert is 10. Since the tree is empty, 10 is inserted at the top of the tree and becomes the root. The next element to insert is 5. And since 5 is less than 10, 5 will become the left child of 10. The next element to insert is 12. And since 12 is greater than 10, 12 will be inserted as the right child of 10. The next element to insert is 8. So since 8 is less than 10 but greater than 5, 8 will be inserted as the right child of 5. The next element to insert is 19. 19 is greater than 10 and greater than 12, so 19 becomes the right child of 12. The next element that we're going to insert is 6. 6 is less than 10, greater than 5, but less than 8. So 6 will be inserted as the left child of 8. The next element that we're going to insert is 2. 2 is less than 10 and less than 5. So 2 will become the left child of 5. Next, we're going to insert 11. 11 is greater than 10 but less than 12. So 11 becomes the left child of 12. Next, we're going to insert 15. 15 is greater than 10 and greater than 12, but it's less than 19. So 15 becomes the left child of 19. Next, we insert 9. 9 is less than 10, greater than 5, and greater than 8. So 9 becomes the right child of 8. And finally, we go to insert 7. 7 is less than 10, greater than 5, less than 8, and greater than 6. So 7 becomes the right child of 6. And that's the tree after all of the insertions. Next, we go to remove elements. The first element to remove is 7. Since 7 has no children of its own, we can simply just remove 7. The next element that we're going to remove is 12. 12 is a bit more tricky because it has two children, 11 and 19. So in order to do this, we have to find its successor. The successor is defined as the leftmost node on the right subtree. So, for example, in this example with 12, the successor is 15. So in order to delete 12, we will copy 15's data to this node, and then we will delete the successor. So the 15's data will be copied here. The next element to remove is 8. For 8, you have to do more or less the exact same thing. 8 has two children, 6 and 9. So we find the successor, which is 9, and we copy its data to this node. Then we delete the successor. So 9's data will be copied here, and then the successor is now deleted. Finally, we go to remove 10. 10 is the root of the tree, but again, it has two children, 5 and 15. So what we do is we identify the successor, which is 11, and then copy 11's data to the node, and then we delete the successor. So 11 is now the new root, and the successor is killed. And this is the final tree after all the insertions and all the removals.